Hi everybody, welcome to physics teacher classes. Yeah, our class is force. So in that we are learning different types of forces. Yes or no? Yes, different types of forces. So as a part of different types of force, we learned already non-contact forces. Right? What are non-contact forces? With examples also we have seen. Today we are going to learn about contact forces. What are those? Contact force. Okay, how many contact force are there? Yes, 4. Already we learnt. Yes, what are those? One is muscular force, or it can be called as applied force. Yes. Second one is, what is second? Friction. Okay, next, third one, tension. Okay now, and what is fourth one? Normal. Yes, these are the 4 contact forces. Now come on, first let us learn about muscular force or applied force. Okay, muscular force or applied force, and it is denoted by F. It is denoted by simply F. So already we learnt. So whenever you are learning about a force, you should learn 3 things. One is its definition, second one is when it acts, third one is its direction. First let us see its definition. Its definition is the applied force is nothing but, it can be called as muscular force also. So the force applied by muscles of human body or machines, okay, or through any connector, that is called applied force. Let us see examples. You are pulling a bag. You are pulling a bag. Means you have in contact with the bag. Right, Nana? Your muscles are applying force on the bag. So it is a muscular force. Okay? Or else there is a bulldozer which is collapsing the house or any building. Okay? This also communicated as applied force. Okay, or else there is a bag, and for that bag you tied a rope or a string, okay na, and you are pulling it. This is also applied force, you can call, because you have a connector. With the help of the connector you are pulling it. Okay na? So applied force is nothing but the force applied by the muscles or the force applied by the machines or through any connector. That is called as applied force. Okay, sir. So that is the definition. Second one is when it acts, when there is a muscle involved in that muscle force, when there is a machine involved in that, or when there is a person involved in it. Okay, you can understand because applied force is given directly in the problems itself. Okay, now its direction also will be given in the problem itself. Okay, now when you are solving the problem, this applied force will be given along with the direction. So don't worry about that. Now let us see second one. So second one I will be taking normal force. What is that, Nana? Normal force. Yeah, it is denoted by letter N. Normal force is denoted by letter N. Now come on, what is meant by normal force? Before going to learn this normal force, let us see, there is a table, for example. There is a table. On the table, you placed any book. Okay, you placed a book. Simply. Right? So, already we learnt gravitational force acts on the object. Downward. Okay, there is a gravitational force on the book also. But why the book is not coming down, not falling down? Book must fall down because gravitational force is acting. Why the book is not falling down? Very good, because the bench is supporting that. Bench is supporting to that. Means the bench is applying force opposite to the gravitational force on the book. Yes or no? It is balancing the force applied by the gravitational force. Who are balancing? Table. If the table is removed, then what happens? The book falls on the ground. That means the table is giving support to this force. Yes or no? So this is applied in the upward direction in this case. Okay, this force is called what, Nana? Normal force. What is this? Normal force. How to define this normal force? The force applied on an object perpendicular to the surface. Perpendicular to the surface. Okay, what is that? It acts perpendicular to the surface. Clear? For example, the surface is like this. Now the book is on this, like this. Then which direction normal force acts? Normal acts always perpendicular to the surface. This is the surface. The surface applies normal in this manner. Okay, this is normal. See here, this is the normal. Here, this is the normal. This makes an angle 90 degrees with the surface. Clear? Now this is the definition. Second thing is when it acts. When there is a contact between two objects. When there is a contact between two surfaces of the objects. Okay, sir? Definition is what? The force which acts perpendicular to the surface is known as normal force. Second thing, when it acts when there is a contact between two surfaces. Clear? Right. Third one is, what is its direction? What is its direction? Perpendicular to the surface. What is its direction, sir? Perpendicular to the surface. Understood the 3 points? Yes. One is its definition. Okay. Second one is when it acts. And third one is direction. Clear, Nana? Once again, very important. Normal force is nothing but the force which is perpendicular to the surface is known as normal force. Second one is when it acts. Right. It acts when there is a contact between the two surfaces. And third one is, what is its direction? It is always perpendicular to the surface. Clear? Very good. Now coming to third one. Let us see third one. What is that? Tension. Okay, it is denoted by capital T. See, applied force F, normal force N, tension T. Okay, you don't feel any tension. It is very easy. Right, Nana? Tension means what? When tension comes, and what is its direction? Let us see. So first of all, what is its definition? Before going to learn its definition, let us see a simple thing. Suppose this is a ceiling. Okay, ceiling of any building or roof. When I keep a rope or string, what happens? It looks like this. Okay, this is a rope, or you can take this as a string. String means, you know, I think for violin or guitar it will be strings. Alright. Now this is rope or string. Whenever you connect this to a rigid support and it freely it suspends. Yes. Now what happens when I tie any object here? When I tie an object here, what happens? Yes, you see that there will be a tightness in the string. Yes or no? You will be observe a tightness. Yes or no? Yes. That tightness in the string or rope is called tension. Very simple. What is that? The tightness in the string or rope is called tension. Clear, Nana? Right. Why this tightness has come in the rope? Okay, na sir? Why this tightness has come into the rope? See here, this is the body. We know that this body is on the surface of the earth. Okay, whenever the gravitational force is acting on this body, it should fall on the ground. But now in this case, it is not falling. Okay, gravitational force is acting downward, but it is not falling. That means some other force is balanced by that. Some other force is balancing the gravitational force, which is that is the force applied by the string or rope. Okay, in which direction it is applying? In the upward direction. Okay, na? That force we are calling as what, Nana? Tension. Clear? So what is the definition of tension? So the tightness occurred in the string or rope when an object is connected is known as tension. When it acts when there exists a rope or string in the given problem or situation. Right, Nana? And for that rope, a body must be suspended. Then otherwise there should be a tightness in the string simply. Right, Nana? Next, third thing, what is its direction? So its direction is tension always pulls the body. Remember that. Tension always pulls the body. Remember this, very important thing. Okay, na sir? So by using this you can identify the direction. See here, it is pulling. Okay, na? So if I connect in this way, okay, na? What happens? In which direction tension will be? This is the string. Pulling means this side. Okay, this side will be the tension. Here upward is the tension. Okay, so you remember that tension always pulls the object. So whenever you are solving the problems, you can understand it very easily. Clear, Nana? It's a definition, when it acts, and what is its direction. Clear? Right. So three things are completed. Next, what is the fourth one? Friction. What is the fourth one? Friction, or frictional force. It is also denoted by small f, Nana. It is denoted by small f. Okay. Now see here. Frictional force means what? So first let me define this, afterwards I will explain. So the force which opposes the relative motion, between the two surfaces, which are in contact. This is a simple definition for frictional force. What is that? Which opposes the relative motion, not motion. Remember this, very important. Okay, friction opposes the relative motion. Okay, so the force which opposes the relative motion between the two surfaces when they are in contact. Okay, when two surfaces are in contact and there is a relative motion, then the force which opposes the relative motion is known as frictional force. General example I will take and I will explain. Suppose you take a rubber ball and roll it on the floor. Just throw it on the floor. What do you observe? It stops after traveling some distance. It comes to rest. Yes or no? You have given some initial velocity. Just you push it. Then it is traveling with some initial velocity. After traveling some distance, it comes to rest. Yes or no? So as you learned that to stop a moving object, force is required. Yes or no? We learned in effects of force. This is the moving object. To stop the moving object, force is required. But here you can see no force is acting on the body in the opposite direction to stop it. Okay, then which force is acting? That is the force applied by the surface. That is the force applied by the surface on the ball. Okay, in opposite direction. That is called what, sir? Friction. Here friction opposes the relative motion. As the ball is moving in the forward direction, so the ground tries to push it back. Okay, so that eventually the body comes to rest. Slowly the body comes to rest. Okay, so this force we are calling as friction. Clear, sir? So many examples are there on friction. So when you are riding bicycle, so you apply brakes. When the brakes are applied, the brakes provides a friction there so that the bicycle causes rest. Okay, na? So this is another example. Now let us see next thing of this one. So when it acts, when friction acts, very important, Nana. When frictional force acts. Now see here, one thing is the surface is rough. Okay, the surface is rough surface. In problems or in the questions it will be given. Okay, if the surface is smooth, then you should not consider the frictional force. When the surface is given as smooth, if you find this word in the problem, you should not consider the friction. You should forget about this. Whenever they say the surface is rough, then friction comes in the problem. Okay. Now, this friction also comes when there is a relative motion. When there is a relative motion, then only friction comes. Relative motion means what? With respect to one surface, another surface should move. Okay. Now see here, with respect to the surface earth, the another surface of the ball is moving. Okay. Now let us see some of the examples. So here, this is an object placed on the surface. Now the object is at rest. Okay. What is the friction in this case? The frictional force in this case is 0, no doubt. Okay, why sir? Because there is no relative motion. Even though there are two surfaces in contact, the surface of the floor and the surface of the body, both are in contact. Okay, na? Surfaces are in contact. But there is no relative motion. No surface is in motion. Okay, in this case, what is that? The frictional force is 0. Now tell me in the second case. Now there is a surface. Now the same object is placed on the surface. Now there is an applied force F. I am pushing it, or you are pushing it, but the object is at rest in this case also. In this case also, the object is rested. Now what is the frictional force in this? The friction force is not equal to 0. Why sir? There is no relative motion. Why? But the applied force is balanced by some other force. Yes or no? Okay, when you apply force, it should move. It is not moving, means some force is balanced by this force, by the surface. The surface applies a force which is opposite to this to balance the applied force. Okay, that force is friction here. The body is trying to move under the application of force. Okay, in this case the friction is not 0, and the frictional force is equal to applied force. How much is the magnitude of frictional force? Is equal to the applied force. Yes or no? If this is 2 Newton, friction also will be 2 Newton in magnitude, but both are in opposite direction. Understood? Okay, if you apply 10 Newton but the body is not moving, what is the frictional force here? 10 Newton. If you apply 8 Newton, body is not moving. How much is the friction? 8 Newton. Understood, no? So in this way, you can calculate the friction very easily. Clear? Now we learned the definition. We learned when it moves. Okay? When it, right. Now, when it acts also we learned. Now, see the third case. Now, there is an applied force, but the body is in motion. Whatever the frictional force. Here frictional force is not 0, and the frictional force will be less than the applied force. As the body is in motion, the frictional force will be less than the applied force. Clear? Here when it is rest and there is a applied force, frictional force will be equal to F. Remember these things regarding that. Now coming to direction. Coming to direction of frictional force. Okay. So in which direction it will be? Right. So as I said, it opposes, it may not act always opposite to the direction of motion, sir. Sometimes, let us see. In this case, it is opposite to the applied force. In this case also, it is opposite to the motion of the body. Okay. Now let us see. Here is an object. Okay. Let us take this is an object A, and on object A there is an object B. Okay. Now a force is applied on A. A force is applied on A, and the surface of A and B are rough. That also given. Okay. This is the case. Okay. I can give a live example for that. This is a bus, for example. On the bus we kept luggage. Okay. When the bus is moving, will our luggage comes along with the bus or falls there? Okay, this is our bus, Nana. On the bus, we kept our luggage on the top of the bus. As the bus is moving, our luggage also comes with the bus or falls here. It comes along with the bus, yes or no? That means body B also has motion along with A. But on body B, there is no force, applied force. Applied force is on A, yes or no? So the force which causes motion here is the frictional force applied by body A on body B, means the surface of A on B. See, in this case, the frictional force is along the direction of motion. Yes or no? Understood? So the body is moving in this direction. Friction acting on body B is in this direction. Okay, this is the frictional force applied by A on B. Clear? So in this way, one can identify the direction of frictional force. Clear, Nana? These are the 4 contact forces. Okay, one is, what is that? Already we learned muscular force or applied force. Second one is normal. Third one is tension. Fourth one is friction. Okay, so remember these are very important one. Okay, so in our coming Newton laws of motion, we will see more applications and how to solve problems regarding this. If you learn these contact and non-contact forces, half of the mechanics will be very easy to you. Okay, this, remember my point. So if you learn when and what is the direction of the forces, you learn perfectly, then mechanics, total mechanics will be very, very easy to you. So concentrate on this. Okay, once again, you see the video if you did not understand any part of this. Thank you.